This lesson is about inequalities, how to find their solution set, and how to graph them. The first thing we want to do is look at graphing inequalities and what their solution sets look like. Let's look at the first example, x is less than 2. Another way to write this is the set of all x's such that x is less than 2. Over here in the number line, we have to represent all the values of x that are less than 2. Usually we do that with just a solid line. I'm going to use an arrow at the end just to show that this goes on forever. Now at 2, I want to indicate that it's not included. So the number 2 itself is not an answer. To do that, we use an open circle. In the next example, I want the set of all x's such that x is greater than or equal to 1. So now the answers are all larger than 1, everything in this direction. Now this one's a little bit different because the number 1 is actually included. I want to demonstrate that by putting a solid dot. The last example here is a little strange just because the x is on the right-hand side. So before I do anything else, I want to turn it so that it looks more familiar. The pointy part, or indicating this less than side, is pointing towards the x. So if I turn this around, I want to keep that pointy part facing the x. So it looks like this. These are the exact same inequality. So I'm trying to graph the solution set, the set of all x's, such that x is less than or equal to 3. That would mean all the numbers to the left of 3. Since there's an equal sign, I'm going to indicate that with a solid dot at 3. Now let's look at some inequalities that need some work done to them. The first example here is x minus 3 is greater than negative 1. To solve an inequality, just pretend that the inequality symbol is an equal sign. We want to move everything away from the x, get it by itself. X is currently being subtracted by 3, so I want to do the opposite and add 3 to both sides. Now, keeping that same symbol, I now find that x is greater than negative 1 plus 3, which is 2. Just for practice, let me go ahead and graph that solution. I want an open dot at 2, and then I need to show that everything greater than 2, or to the right of it, is included. For the next example, 4 has been added to x. So in order to get the 4 undone, I want to subtract it. Keeping that same symbol, the less than symbol, I find that x is less than 1. There's no equal sign, so this is going to be an open dot as well, but I want all the numbers that are to the left of 1. Okay, let's try this next example. I want to get x by itself, so I have to undo the plus 6. I'm going to do that by subtracting 6. Five minus 6 is negative 1, and so I get negative 1 is greater than x. This is that same situation where we had before, where the x is on a different side. Let me rewrite this so it says x is less than negative 1. Notice how the pointy part of my symbol is still facing the x. This is telling me the answer is everything less than 1, or less than negative 1. Now there is one small catch with solving inequalities, and that's with multiplication and division. The multiplication-division property of inequality says that any time you multiply or divide by a negative number, you have to change the sense of the sign. That just means you change the direction. Now, even though we worked with negative numbers by adding them or by subtracting them in the previous examples, we didn't multiply or divide by any. So now this is something you'll have to keep track of. Every time you multiply or divide, think to yourself, do I need to change this symbol and put it in the other direction? So let's start doing some problems that involve multiplication and division. For the first one, I'm going to divide by 2. Now I'm dividing, but everything's okay on this, and that's because I'm not dividing by a negative number. Here, x is greater than 2. In the next one, it's a fraction, but it doesn't make it any more difficult. We just need to undo it. For a fraction, you can divide by 3/4. Or, better yet, let's multiply by its reciprocal, which is 4/3. That means x is less than or equal to 4/15. Even though I multiplied, I did not multiply or divide by a negative number. So we keep the sense of the sign exactly the same way. In this last example, I'm dividing by -3 to get x by itself. This should throw up a big red flag right here. I've now divided by a negative number, so I'm going to change the sense of the sign. It was a greater than, now it's going to be a less than. Let's try a few more. This is a 2-step equation, so I'll have to do multiple operations. I'm going to start by undoing the -3. I'll do that by adding 3 to both sides. This gives me 4x is greater than 12. To finish, I'll divide by 4. Even though I'm dividing, I'm not dividing by a negative number, so we just leave the sense of the sign alone. Okay, last example from this section. I'm going to get the n by itself. I'm going to start by subtracting 5 from both sides. This gives me -3n is less than 6. But here, I'm going to have to divide by a negative number. So a red flag goes up. I'm going to switch the sense of the sign. It was less than, now it's going to be greater than. N is greater than -2.